Everyone, Ismail is here. Today we are going to start the lesson 2.5 rational functions. This is before the last lesson in the chapter 2. Here in this lesson we're going to analyze and graph rational function. Then we are going to solve the rational function. Okay, but I will not ask my students to graph. I just need you to analyze the function. Now before we go through the lessons, let's go through this vocabulary. Rational function. Rational function is the function that has asymptote, or the function that has excluded values from its domain. Okay, then the asymptote is the line or the point that has discontinuity. Okay, then the vertical asymptote means when you have a vertical and you graph, it never intersect this one here. It will go next to it, it will never cross as vertically. Horizontal asymptote, it's line like this one, but the horizontal asymptote, sometimes the function can intersect the horizontal asymptote. So the horizontal asymptote is allowed to intersect it, but the vertical never can be intersected. Then we have the oblique asymptote. The oblique asymptote when you have a diagonal line. Okay, so the diagonal line, so the function will just go next to that line. Okay, or on the other side the function will go next to that line, so it's just like diagonal one. Then holes means when you have a graph like this, when it's discontinuous at one point, then you complete the point. So as you can see, this is the holes meaning. Okay, now after we know the meaning of every vocabulary, let's go next to the rational function. Now the rational function here, it's already known and we already explained it, which is any function that has excluded value, excluded from its domain. And as you can see, this one here represents the vertical asymptote. So the vertical asymptote here is equal x equals 0, because you know that the vertical, it's always represented by vertically, but when we write it, when I ask you to graph x equals 0, so you graphed it as vertically. Okay, the same thing here when I said about horizontally. Okay, so this can be drawn by y equals 0, because you know when I ask you y equal 5, you graph y equal 5 like this, but when I ask you x equal 3 example, so you graph x equal 3 like this. So this is the difference between the vertically and horizontally. Okay, this is some two examples. Okay, this is the horizontal asymptote and this one here is the vertical asymptote. Okay, now let's go here. We summarize this lesson. Thank you for the teacher that I took this one from. Okay, now there are following steps summarized to process, graph, analyze rational function. Now I just summarize it in this way. If you memorize these 4 or 5 steps, okay, the analyzing is completed. Now the first thing that you need to do when the polynomial is given, you need to find d, which is standoff domain. First, try to find the domain. And how to find the domain? You need to set the denominator, okay, denominator equal with 0, then you solve and you find the excluded value. So the domain will be from -infinity to the excluded value. Okay, what's the excluded value? Union with the excluded value sometimes, okay, to positive infinity. Okay, or sometimes there is a point here, then you complete the domain. Okay, now the next step is to reduce. Okay, now redur, which is standoff reduce. Reduce means what? Reduce means try to factor. Okay, so you need to try to factor the possible. You need to factor the function, okay, if possible. So factor the expression means if you have example x plus 2 and you have here x plus 3 and here x plus 2, okay, so you need to cancel these two together, then the function will become 1 over x plus 3. Okay, so there will be a whole at x equal, okay, -2. Okay, now you need to start or sometimes if the function given as x squared plus example 9x plus example 24, so you need to factor this one, okay, and the factor that you will get here also simplified. Okay, so this is the second step. Third step, which is I. Okay, I is a stand from intercept. Okay, intercept, which is y-intercept and x-intercept. Okay, intercept. Then, so to find, okay, y-intercept first, to find y-intercept, plug in x, oh sorry, plug in 0 for every x. Okay, so plot 0 for every x. Okay, then you can find the y-intercept. Also, to find the x-intercept, okay, to find set y, okay, set y equal 0, or you can say set f of x equal 0. Now the next one is the vertical okay, vertical asymptote. So what is the vertical asymptote? How can I find the vertical asymptote? To find the vertical asymptote, I wrote it in blue color in purpose because the vertical asymptote, it's more, let's say, more same as the domain, which is set the denominator, okay, equal 0, then solve vertical asymptote. Some question it doesn't have the same thing, but we will see some example. You will see. Okay. Now the last one here is the, what do you think it should be? Is the horizontal asymptote. And let me write here horizontal. Okay, horizontal asymptote. Now what is the horizontal asymptote? Okay, the horizontal asymptote, we need to look at the what of and. You know that the rational function is example x to the power of 3 and here x to the power of 2. Now what we need to look, we need to look to the degree for both of them. So look at the degree, okay, of the numerator, which is this one here, and look to the degree for the denominator, okay, which is this one here. Now if the numerator is less than denominator, so the horizontal asymptote y is equal 0. Okay, so the horizontal, you just write ei equals 0. Now if the numerator degree is equal to the degree of the denominator, then the horizontal asymptote will equal a over b. What's a over b? It's the constant. What's the constant here? It's 1. What's the constant here? 1. So y, it should equal 1 over 1. So y, the horizontal asymptote, it will be graphed on y equal 1. So this is the horizontal asymptote. Sometimes the question will give you example 2x to the power of 4 over 3x to the power example 4. So they are equal. So we can just say that the y is equal to over 3. Okay. Now the last one, when the numerator is greater than denominator, then no horizontal, okay, no horizontal asymptote. So but there is small situation that you need to memorize when the numerator is greater than denominator. Now we know that when the numerator is greater than denominator is no horizontal asymptote, but okay, keep it in your mind, but let me write here but if the degree, okay, if the degree, let's say if the degree of, okay, numerator is greater than denominator by 1, okay, so there will be oblique, okay, oblique asymptote. So keep it in your mind. When example, for example, if I have like this, let's say I have x to the power of 4 and here x to the power of 3. Now the difference between 4 and 3 is only 1 degree, so there is no horizontal asymptote, but there is, yes, for what? For oblique, okay, asymptote. Okay, so just keep it in your mind. If it's the difference is only 1, so there is no horizontal asymptote, and yes, for oblique asymptote. If the function example 5 and here x3, the difference between them it's 2, it's not 1. So that's mean no horizontal asymptote, okay, and there's no oblique asymptote for both of them. Okay, I hope you understand this. Now you need to memorize. You need to find all of these. Okay, domain, reduce, intercept, vertical asymptote, and horizontal asymptote. Then to analyze any equation. Now let's start takes one first example. Just warm up. Now let's read the question. Find the domain. Okay, the question, you need to find the domain for each function and equation of the vertical or horizontal asymptote. Okay. If any. Now, we need to find three things. The first thing is the domain. The domain for the first function, we need to set the denominator equal 0, x minus 4 equals 0. So that means x is equal 4. Now, my domain will be from negative infinity to 4. 4 will be the excluded value. From 4 to positive infinity. Now, how about the vertical asymptote? We said that the vertical asymptote is same as the domain, so we can say the vertical, let me write here, vertical asymptote at x equal 4. Then, what's about the horizontal asymptote? The horizontal asymptote, we need just to take look to the degree. Now, the degree here is 2. The degree here is 1, okay? So we can say 2 is greater than 1. So of course numerator is greater than denominator. Because the numerator is greater than denominator, there is no horizontal asymptote. But is the difference 1 between them? Yes. So there will be oblique asymptote. Yes, for oblique asymptote. We don't need to find it now. We will find it inshallah later. Now, how about this? What's the domain for this graph? So the domain for this one is x equal 1, negative 1, sorry. And here x is equal to 3. When I write the domain, negative infinity to negative 1, okay, union. Now from negative 1 to positive 3, union from 3 to positive infinity. Okay? Now, how about the vertical asymptote? The vertical asymptote, same thing. We have a vertical asymptote at x equal negative 1 and x equal 3. What about the horizontal asymptote? The horizontal asymptote, look to the degree. How many x here? 1. How many x here? So I have 2 x's. How many x here? How many x here? I have 2 x's. Now, are the x's same? 2 is equal to. Because 2 is equal to, which is the numerator is equal to the denominator, the situation should be a over b. And what is the number in front each x? It's 1, 1. So we have to write 1 here. And here also is 1 and here also is 1. So it's also 1. So 1 over 1. So we can just justify the horizontal asymptote is y equal 1. Okay? I hope you understand this. Now, let's start analyze the function. I wrote for you a table here to make it easy to you to identify every part, but in the exam or in a quizzes, the table will not be given. It will just ask you to analyze the question. Find each, determine any asymptote, okay, and any intercept, okay, if the graph then state the domain. So everything we need to find here. And as you can see, the graph is given for us, okay. Sometimes the graph is not given, but I just wrote the graph for you to make things clear, okay. Now, let's find the domain. The domain, we need to take the denominator equals 0. x plus 2 equals 0 and x minus 1 equal 0. So the first x is equal negative 2. Now the second one is x equal 1. I have 2 excluded values, so when I need to write the domain from negative infinity to negative 2, union from negative 2 to 1, union from 1 to positive infinity. Okay? Now as you can see, this is how we can find the domain. Now reduce help us to find holes. Now is there anything can I simplify here or here? Is there anything can I cancel? No, because I can't cancel, I can't simplify, so we can just say no holes. Okay, no holes at any point. Now intercept. So to find y-intercept, we need to set, okay, x equal what? Set x equal 0. So now if I set this one is equal 0, this one is 0, this one is 0, this one is 0, so this part cancel, this part cancel, this part cancel, this part is cancel. So it's remaining 3 multiplied with negative 6. 3 times negative 6 is equal negative 18. And 2 times negative 1 is equal negative 2. So the answer is equal 9. So we can just say the y-intercept is equal 9. And this is what you can see in the graph. If you look on the y-intercept here, so this one is, okay, is equal 0 and 9. Oh, okay. Sometimes if you want to write it like this, you can write like this, but I prefer to write it as coordinate because coordinate it's much easier to understand. Okay. Now, how we can find the x-intercept? So to find x-intercept, set y equal 0. And if I set y equal 0, now as you can see, this is a rational function. And I will give you easy way. Just take the numerator, okay, equal with 0 and solve it. Okay, so now if I take 2x plus 3 equals 0, and if I take x minus 6 also equals 0, so the first x here, let me write it here on, okay, so it should be minus 3 from both sides, minus 3, so it becomes 2x equal minus 3, then divide by 2, so x is equal negative 3 over 2. So this is the first x. Now the second x is equal 6. Okay, so I have two x's. The first one is x equals 6. So on the graph, this one here is 6 and 0. And the other point here, which is written here, negative 3 over 2 and 0. Okay, I hope you understand this. Now the vertical asymptote is same as the domain as we mentioned before, which is the vertical asymptote is at x equal negative 2 and x equal 1. Okay, now after we can identify x equal 1 and x equal negative 2. As you can see, if I graphed a vertical asymptote at 1, you can see now the graph, it goes close to a vertical asymptote, but it will not touch it. Then also x equal negative 2, this is negative 1, so it should be here. And as you can see, the graph will go close to the negative 2, but will never intersect with the vertical. Now let's find the horizontal asymptote. We know that the horizontal asymptote is to take the degree for the numerator and the degree for the denominator. Now let's look to the degree for the first one. I have here x and I have here x, so I have 2 x's. Same thing with the denominator, I have 2 x's. So now they are equal. The numerator is equal denominator. So I have to take y equal a over b. Now what is the number here? It's 1. What's the number here? Is 2. So 2 multiply with 1, it's 2x squared. And here is 1, 1 times 1 is 1. So as you can see, 2x squared over 1x squared, we can just take only the constant y is equal to over 1, which is equal y equal 2. And as you can see, where is y equal to? So y equal to is on this one here. So this is the horizontal asymptote, and as you can see, the function will go with the horizontal asymptote. Okay, and as you can see, the graph in the middle is intersecting the horizontal asymptote, which is completely fine when you intersect. Okay, I hope you understand this. Now let's take one more example here. Okay, for each function, fine. Now I will try to, let's say, move fast while I'm solving too, because we have a lot of examples. I don't need to make the video very long. Now let's find the domain. So the domain, we set this the denominator equals 0, but before we set this one, let's factor it. What are the factors for the denominator? The factors of negative 24, that will give me negative 5. I have negative 8 and 3. So let's write x equal negative 8 and x plus 3. Okay, now the domain will be so x is not equal 8 and x is not equal negative 3. The domain will be from negative infinity to 8, sorry, to negative 3, not 8, first from the small to the big, negative 3 union, then from negative 3 to 8 union, then from 8 to positive infinity. Now reduce. Let's simplify this. As you can see here, this I can't simplify anything because look to here, this one, x minus 4, x plus 6, and here x minus 8, x plus 3. So I can't have, or let's say, no any simplifying, so no holes and no simplifying. Now intercept. So to find y-intercept, x should equal 0. Now let's do it on the here on the graph. If I replace every x with 0, so this one 0, 0, 0, 0, 0. Okay, now this term, because this one is 0, it's multiplied with the whole bracket, so all the numerator will become 0. Okay, and if I put this one 0 and this one 0, okay, it will become negative 8 times 33, which is equal negative 24. So the answer is 0 over negative 24. So the answer is equal 0. So the y-intercept is equal 0, or we just can say 0 and 0. And this is what you can see here. The graph at the y-intercept is 0 and 0. Okay, now the x-intercept, okay, to find x-intercept is to set y equal 0, and as I ask you, take only the numerator equal 0. So if I take only the numerator equal 0, okay, so it will be 0 equal x multiplied with x plus 6 square and x minus 4. So the first 0 is x equal 0. The second 0 is x equal positive 4. Okay, now how about this one here, x plus 6 squared? X plus 6 squared means this bracket is repeated twice, x plus 6 and x plus 6. So if I need to find the 0, so the first 0 is x equal negative 6, and the other 0 is x also negative 6. So it's repeated 0, so you don't have to take both of them, just take one. So the third 0 is equal x equal negative 6. Now if you look to the graph, this one here is 4 and 0, which is the first 0, and here is the 0, 0. Okay, and here in the third one is the negative, okay, negative 6 and 0. Okay, I hope you understand this. Now the last one, the vertical asymptote. The vertical asymptote, as I mentioned before, is the same as the domain, and as you can see, the domain is only 8 and negative 3. So the vertical asymptote at x equal 8 and x equal negative 3. And if you look to the graph, where is x equal 8? X equal 8, this is 9, so it should be here. Okay, and as you can see, if we complete the graph also will go next to this one. Then we have x equal negative 3, negative 1, negative, so negative 3 should be here, and this one is negative 3. This is the two vertical asymptote. Now how about the horizontal asymptote? The horizontal asymptote, look to the power. So as you can see, I have one x here, and I have here, it's not 1x because it's square, so I have 2 x's here. So 1x, and here 2 x's, so x cubed, and I have 1x here, so x to the power of 4. And here down, same thing. How many x do I have? The highest degree is 2. Okay, so I have the numerator is greater than denominator, because it's x to the power of 4 over x to the power of 2. And because the numerator is greater than denominator by 2 degrees, we know that the rule says the numerator greater than denominator by 2 different degrees. So there is no horizontal asymptote, and there is also no oblique asymptote, because it's greater than denominator by 2. Okay, now after we finish these 3 examples, now it's your turn to try to solve these 3 questions. Try to solve them, and if you need help, please let me know.